Okay, so we want a can to be able to hold 30 cubic inches of liquid. So this in your mind should be going off as volume because we're trying to hold 30 cubic inches of liquid. And also it's saying what is the minimum surface area of the can. So what we need to do is these equations were on the board today and you'll have them at the test, but the volume of a cylinder, in this case it's 30, is equal to the area of the base, which is pi r squared, multiplied by the height. Okay, so that's our volume. And what we want to do is we want to minimize our surface area, which is equal to 2 pi r squared plus 2 pi RH. Okay, so let me move this down actually so I can work with this other guy a little bit. So what we want to do is we want to graph surface area, because if we can graph it, then we can easily look for a minimum. But the problem is we can't graph it right now, because right now we have surface area as its own variable, and then we have R and we have H. That's 3 variables. We can't graph it. We need 2 variables to graph. But we do have given information. We know that the volume is equal to 30. So we can use that information to isolate one of our variables. We're going to divide the whole thing by pi r squared. So that means H equals 30 divided by pi r squared. Okay, so this is good. What we do know is we know surface area equals 2 pi r squared plus 2 pi RH, and we know that H equals 30 over pi r squared. So we can take that H and we can just plug it directly in for the H in our surface area formula. So what we're going to get is we are going to get surface area equals 2 pi r squared plus 2 pi r times 30 over pi r squared. Okay, when I put the graph on, I'm going to put it on in 2 different ways so you can see that both ways work. But we can just leave it like this. We could be done, or we could simplify this, which actually doesn't end up being so bad. So to simplify, we're going to get 2 pi r squared plus 2 pi, okay, so really quick, 2 times 30 is going to give us 60. And then we have a pi r on top, it's going to be on top of our equation because the 2 pi r is going to go in the numerator. So we can cancel the pi r, we can cancel the pi, cancel one of the r's. So what we're going to get is we're going to get 60, okay, pi r over pi r squared. And then the pi's cancel, and then one of these r's cancels, but it leaves one of the r's down there. So our final equation is going to be 2 pi r squared plus 60 over r. On the test, I'm not going to make you simplify, but you do need to get the correct graph. So what we're going to do now is we're going to graph this and see what the minimum is. Okay, so here's the graph you should be getting. If you could have graphed this guy without simplifying, so the 2 pi r squared plus 2 pi r times 30 over pi r squared, as long as you're careful, okay? Now remember, we're using x because that's what Desmos is going to register as our independent variable. So x actually represents r in this case. So then that means that the radius is this value, because again, x represents r, and the x value comes first. So that tells us that the radius equals 1.684, and then the min surface area, if we want a volume of 30 cubic inches, is 53.448 inches squared. Okay, and that is our final answer. Now this graph represents all the possible surface areas for a volume of 30. So if we make our radius a little bit bigger, our surface area is going to be bigger. And if we make our radius a little bit smaller, our surface area is still going to be bigger. We have to adjust all the dimensions, so we're still going to hold 30 cubic inches of volume. So our surface area goes up. So this represents the minimum possible surface area given us a volume of 30.